So the limit of a function of f of x is a mathematical tool for investigating the behavior of f of x, the y values, as the value of x gets closer and closer to a number. Okay, you're just basically looking at the behavior, be like, okay, hey, this is a curve. What is happening to this curve as I'm approaching the value 3 on the x-axis? Is it getting bigger, smaller? Is it approaching a certain point or a certain y value? What is it exactly doing? So we want to write the limit as x approaches a of f of x is equal to L. So we're going to read this. The limit of f of x as x approaches a is equal to the number L. Okay? So the values of the function f of x become closer and closer to the number L as x gets closer and closer to the number a from either side. But x can never equal a. It will get closer and closer, but it will never be a. F of x does not need to be defined as x is equal to a. What matters is how f of x is defined near the a value. So we've done this before, where we've used a table of values to figure out what the limit of the function is. So we're just going to go over that briefly. So we're going to determine the limit of the function f of x squared minus 2 as x approaches a value of 1. So what we're doing is we're going to evaluate the limit as x approaches 1 for f of x. Okay. So we want to see what it does as x approaches 1 from the left and as x approaches 1 from the right. Okay. So we're basically taking values less than 1 when we're approaching our x value from the left and taking x values greater than 1 when we're approaching x is equal to 1 from the right. So we're going to take the values 0.9, 0.99, 0.999, and we're going to see what it is doing. So if I sub in 0.9, my y value is going to throw me 1.19. We're going to get 1.0199. And we're going to get negative 1.001999. So what is my limit of x approaching 1 from the left of x squared minus 2? What is it approaching? If we look at our table of values, what is it getting closer to? Negative 1. Thank you, Anna. It's getting closer to negative 1. Now let's take approaching 1 from the right. So if we sub in 1.1, we're going to get negative 0.79, then negative 0.9799, then negative 0.997999. So what is my limit getting closer to from x approaching 1 from the right? It is going to be, again, negative 1, which means that as x approaches 1 from either direction, f of x gets closer to a value of negative 1, which means my limit basically is negative 1. So now if I were to draw the graph, it would make sense that negative 1 is the answer. So we have our Cartesian plane. My vertex is going to be 0 and negative 2. And it's a parabola that opens up. So we read graphs from left to right. And let's say negative 1 is over here. So as x approaches 1 from the right, sorry, whoops. So as x approaches 1 from the right, as we can see, we're going to get a negative value over here. So this is 1, it's going to be somewhere here. So as it approaches it from the left or to the right, it is going to get closer and closer to negative 1, because that's going to be our y value. which means therefore the limit as x approaches 1 of f of x is equal to the limit as x approaches 1 of x squared minus 2, which is equal to -1. Note that when we actually input -1 into our equation, we get -1, which makes sense because our limit is approaching that y value as we get closer and closer to x is equal to 1. So here are some proofs. So if the limit as x approaches a from the right is equal to L, and the limit of x approaching a from the left is equal to L, then the limit of x approaching a of f of x is equal to L. Okay. However, if the limits do not equal to each other, then the limit doesn't exist. We're going to do some examples with some graphs. So we want to use the graph to find the limit, and we need to figure out if it exists. So just by looking at the graph, as x approaches 5, what y value does my graph approach? 2. Okay? So if we approach it from the left or from the right, it's going to approach 2 regardless, which means that the limit does exist. Okay? Which means that the limit of x approaches 5 of f of x is equal to 2, since the limit of x approaching 5 from the right of f of x is equal to 2, and the limit of x approaching 5 from the left of f of x is also equal to 2. Now the next one, what is the limit as x approaches 4 for this function? So the limit of the function does approach 0, okay? However, the point that's actually included of f at 4 is equal to 3, okay? So if you approach it from the left and from the right, does the limit exist for this specific x value? Remember, L has to be the same number for both of them. So the limit does not exist for this one. Okay, how about so for the next one, we have the limit as x approaches 1 of f of x. So as the limit approaches, x is equal to 1. Oh, so the 3 is the point up here. So as you can see at f at 4, we have 2 different points. We have 0, which is not included, and we have a random point 3. So the next one, remember, as the limit of x approaches 1 of f of x, does the limit exist or not exist for c? So remember, think of it as approaching from the right and approaching from the left. So does it exist or not exist? Does not exist. And the reason it doesn't exist is because if we approach 1 from the right, what y value is it approaching? 2. And if we approach it from the left, what y value is it approaching? 0, which means the values of L are not the same, which means the limit of x approaching 1 from the right is not the same as the limit of x approaching 1 from the left. So now the last one, the limits of x approaching 0. So let's take it from the right and from the left. So what is my limit as x approaches 0 from the right? 1. Okay. What is my limit as x approaches 0 from the left? Does anything exist on that side of the axis? No. So what is my limit of as x approaches 0 then? Does it exist or not exist? No, it does not. It doesn't exist because there's no other side of the function that continues on the left side of 1. Okay? So that means it does not exist because there is no section that is to the left of 1. And for B, I made a mistake. I just caught myself. This was my mistake. So this is in fact 0, and the reason being is because as we approach it from the right, it actually approaches 0, and when we approach it from the left, it also approaches 0, but there's also a random point f at 4 is equal to 3. However, the limit does exist because when hitting 4 from the right or from the left, you're approaching 0. I know some of you are confused on this one over here. So the reason why the limit doesn't exist is because there's no continuation of this piecewise function going into the negative axis. So there's nothing to refer to when approaching 1 from the left because nothing exists there, which is why the limit does not exist when x is approaching 0. So does anyone remember what these types of functions are called? They're pretty annoying. I don't know if you guys learned it I know I didn't teach it because we don't really teach piecewise functions. Or I just gave the answer away. It's a piecewise function. They're annoying. And they have a lot of restrictions. Okay. So these are what we call piecewise functions. A piecewise function has different function definition depending of the independent variable. So this is where we're gonna actually sketch one out. So we have example 3, and we have a piecewise function. We have negative x minus 1, where x is less than 1. We have x plus 1, where x is between 3 and 1. And then we have negative x minus 3 squared plus 4, where x is bigger than 3. So now it is up to us to determine some of these limits. But before we do that, we kind of got to sketch our piecewise function out. So when the sign is just greater than, are we going to have an open dot or closed dot at that specific x value? And when it has greater than or equal to, we're going to have a closed dot. So we want to find the limit as x approaches 1 and as x approaches 3. So we're going to start off with the easy one, x plus 1. So it's included over here. And the restriction was x has to be between 3 and 1. So this is going to be my first section of the piecewise function, which is x plus 1. We have negative x minus 1, where x has to be less than 1, so it's going to be an open dot. So if I sub in 1 for x in negative x minus 1, I'm going to get 1 in negative 2. But it is an open circle point, and it would take us going this way. So this is continuous. And then last but not least, we have negative x minus 3 squared plus 4, where x is bigger than 3. So what would my vertex be for that parabola? Let's see if you guys remember. What is my vertex for that parabola? Three and 4. Okay, so it's going to be 3 and 4. So x plus 1. Oh, my bad. I drew this one wrong. This one's 1 and 2. That's where I messed up. Okay, and then we have our vertex at 3 and 4, which means that my graph is going down this way. Okay, so now we're going to be able to find our limits. So for the first one, we need to find the limit as x approaches 1 of f of x. So does the limit exist for that or does not exist for that? And explain why. So remember, we're approaching 1 from the right, and we're also approaching 1 from the left. So what is the limit as x approaches 1 from the right of f of x? What does it hit? Two. The limit of f of x as x approaches 1 from the right is 2. And what is the limit of x approaching 1 from the left? What does that give us? So if you look at our negative x minus 1, what does it give us? Negative 2. So negative 2 and 2 are not the same. So what would our answer be for the limit as x approaches 1? Does not exist. Okay. Our next one is the limit of x approaching 3. So if we approach 3 from the right and from the left, what would my limit be for the next one as x approaches 3? This one should be pretty easy. 4. Okay, they both approach 4 from the right and from the left. So as you can see, you can actually calculate limits through just drawing the graphs instead of using the limit notation formula, which can get a bit annoying. And last but not least, we want to sketch any graph that satisfies the given condition. So the first one, we have f of 2 is equal to 3. So at 2 and 3, we have a point. Next one we have, as x approaches 2 from the right, the limit is going to be negative 2. So I can have a negative 2 over here, whatever, and I can have any function going that way. As long as when I approach the right, 2 from the right, my limit is going to be 2, okay? Negative 2. And then my last condition is the limit as x approaches 2 from the left is going to be positive 1. So we got to make sure that whatever comes on the left side of the graph, it's approaching a value of y is equal to 1. So I could literally have a curve going like this and hitting 1 over here. Because the limit as x approaches 2 from the left is going to approach a value of y is equal to 1. I know it was a bit of a jam-packed session with 3 lessons back to back to back. We still have 2 more lessons in this unit. Okay, so give me 2 seconds. I'm just going to answer the phone.